Good day everyone. In today's video, we are going to talk about another circle theorem, and it states that when two angles are subtended by the same arc, the angle subtended at the center of the circle is twice the angle subtended at the circumference of the same circle. Let us address what it means for an arc to subtend an angle. An arc is just a portion of the circumference of a circle. Let's take this point to be A, and let's take this point to be B. Let's draw a line from A to point C. Let's draw another line from B. In the intersection of the two red lines at C, we have an angle here. Let's label the angle alpha. So here now we can say arc AB, the black line, the black curve rather, arc AB actually subtend an angle alpha at point C. So far the angle is within the sector formed by the two red lines and the black arc. Let's have a circle. Here is a circle. Okay, let us identify 2 points. Okay, let's call this X, and let us call this point Y, so that we can end up having an arc. XY is an arc. So let's identify the center of the circle. Okay, let's say this is the center of the circle. Let's label this as O, and let's identify another point on the circumference of the circle. Okay, let's label this as Z. Now let's draw a line from X to meet Z, another line from Y to meet Z. So we can say arc XY, the arc is the green ink, is actually subtending an angle at Z. So let us label the angle as theta. Okay, so arc XY, which is the green arc, that's the minor arc, is subtending angle theta at Z. Now let's draw how same arc XY is going to subtend an angle at the center. Now from X, let's draw a line to meet the center O, then another line from Y to meet the center O. So we can say arc XY, which is the green arc, the minor arc, is actually subtending an angle at the center. So let's have the angle at the center as this. So what the theorem is saying is that whatever angle you have at the circumference, twice of that angle at the circumference is the angle at the center. So if theta is the angle at the circumference, then 2 times theta will be the angle at the center. Let's take some examples. Now in this example, we are going to, let's start by tracing out our arc AB. Let's have it in green ink. The angle subtended by the arc AB, that's in green ink, note that's the minor arc. So the angle subtended at the center by the arc AB, let's use our red ink to trace that out, and that is going to give us, okay, let's find out the angle subtended at the circumference. Okay, let's use our blue ink to trace that out. Okay, we have this and we have that. So if you follow the blue ink, we can label this place as X. Alright, so that's the angle at the circumference. Let's label it as X. And the angle at the center, that one is 94. Both angles are subtended by the arc AB in green ink. So let's recall our theorem that angle at the center is equals to twice angle at the circumference. So the angle at the center is 94, twice angle at the circumference, 2x. So if we are going to look for our x now, we divide both sides by 2. That will be x 94 divided by 2, and that's going to give us 47 degrees. But we are not actually looking for x. What we are looking for is g. And if we note this now, we can conclude on angle on a straight line. That is x plus g. X plus g. Both angles, if you sum both of them, it will give you 180. Sum of angles on a straight line is 180 degrees. So x is 47 plus g equals to 180. So g equals to 180 minus 47. G is going to give us 133 degrees. In this example, the arc subtending angle 99 degrees and B is actually a major arc. Yes, the longer arc is the major arc. So that's what I'm trying to trace out here. Good. Okay, it's just like having something like this. Now, I told you that if an arc is going to subtend an angle from one end of the arc, you draw a line. From another end of the arc, you draw another line. Yes, good. The intersection of the two lines will give you two angles. But we're interested in the angle on the inside. That's the inferior angle. The inferior angle is the angle subtended by the arc. The angle inside the sector. So if we trace this out now, you will agree with me that angle B is on the inside of the sector. The whole of this place is a sector. So angle B is angle at the center, and the angle subtended by the arc AB at the circumference is 99 degrees. And twice of that will give you the angle at the center. So 2 times 99, that's going to give you 189 degrees. In this example, we are going to attempt to find angle E, that's angle ABO. But what's very obvious in this diagram is that OA is a radius and OB is also a radius, and that makes triangle AOB to be an isosceles triangle. An isosceles triangle has two sides to be equal. That's why we have AO to be equal to OB, and the base angles are also equal. So therefore, this angle is also an E. Okay, alright, so let's label the angle at the center to be a Y. Okay, now we have the angle at the circumference to be 53, and we know that there is a relationship between the angle at the center and the angle at the circumference subtended by the same arc AB. So the angle at the center is Y, and the angle at the center is twice the angle at the circumference. So the angle at the circumference is 53. So twice of that, that's 106. So the angle at the center is actually 106 degrees. So now we have a triangle. We can redraw this now. We can have this way. Okay, and this is our E. This is our E, and this is 106. So remember that this is an R, this is an R. Okay, now we can sum up the three to give us 180 degrees. Sum of angles in a triangle is actually 180 degrees. So E plus 106, that's going to give us 180. So 2E, that's 180 minus 106. So 2E, that's going to give us 74. And divide both sides by 2, 74 divided by 2, and that is going to give us 37 degrees. In this example, the first thing that should cross our mind is that this is the radius. R is the radius. This is also the radius. And BE is a tangent. And the radius intersects the tangent at 90 degrees. So that makes this to be 90 degrees. Here is 90. And here is also 90 degrees. Okay, now we are going to identify the angle at the center, and we can label that using a letter. Let's label that to be X as the angle at the center. Now we have HJCE. E to be a quadrilateral. So we may have to know what value of this one is. That's angle A. Okay, we can extend this line and we call this angle on a straight line. Yeah, so A plus 150 degrees, A plus 152. That's sum of angles on a straight line. So therefore, A is 180 minus 152. And we can say our A is 28 degrees. Okay, so this is 28 degrees. All right, so we can work on the quadrilateral HJCE, and the sum of angles in a quadrilateral is actually 360 degrees. So let's have that. We are going to sum up X, sum up 90, it's 90 and it's 28. So sum of angles in a quadrilateral is 360 degrees. So plus 28, and that's equals to 360 degrees. So X plus 208, that's equals to 360 degrees. So here we can say X is equals to 360 minus 208, and we have our X to be 152 degrees. So S is equals to 152 degrees. That is actually the angle at the center. So considering the theorem, we're considering in this video that twice the angle at the circumference. So the angle at the circumference is actually y. That's the angle at the circumference. So 2y, twice the angle at the circumference, is the angle at the center. The angle at the center is 152. So divide both sides by 2. Y, that's 152 divided by 2. And that's going to give us 76 degrees. Yeah, in this example, it seems it looks intimidating, but it is obviously not. So let's break it down one after the other. Okay, this is a radius. Oh, I have my arrow there. This is a radius. Okay, and so that makes A whole B to be an isosceles triangle. So therefore, the base angles of an isosceles triangles are equal. So if ABO is 60, then BAO is going to be 60. Base angles of an isosceles triangles are equal. Alright, so it seems this is an equilateral triangle. No, it is. It is obviously an equilateral triangle because if the two base angles are 60 degrees, each of them 60 degrees, then here is also going to be 60 degrees. So because the sum of angles in a triangle is 180 degrees, so triangle AOB is an equilateral triangle. Alright, but that's not our main focus here. Now, let's consider arc AB. Now, considering arc AB actually subtend angle 60 at the center. Alright, so I'm tracing it out. Yeah, so that's arc AB subtending angle 60 at the center. Now, the same arc AB now is subtending what angle at the circumference? Okay, let's have it. Good. Just follow my green ink. Alright, good. Okay, so let's label this as y. Alright, so what's the value of our y now? Because arc AB subtend angle y, and that's the angle at the circumference, and the angle at the center is 60 degrees. And so don't forget that twice the angle at the circumference is the angle at the center. So therefore, the angle at the circumference is going to be 30 degrees. So because if we multiply this by 2, 30 multiplied by 2 will give us 60 degrees. All right, it's becoming interesting now. So what about angle 62 degrees? Sorry, I mean 62 degrees. Let's have it. Let's have angle ADC. Angle ADC, that's equal to angle ADB, plus angle BDC, Okay, so what's angle ADC? That should be 62 degrees. And what's angle ADB? ADB is 30 degrees. Okay, and what's now angle BDC? So angle BDC is going to be 32. So angle BDC, we subtract 30 from both sides, and that's going to give us 32 degrees. Okay, so let's have this to be 32 degrees. So this is 32 degrees. So which chord is actually subtending 32 degrees at the circumference at point D? Okay, that should be the arc, sorry. The arc subtending that angle. That should be arc BC. Yes, arc BC is subtending 32 degrees at the circumference at point D. Okay, so what's the angle at the center that arc BC is subtending? Okay, let's trace it out. That's going to give us, let's trace this one out first. At the center, at the circumference, Okay, good. So we can see arc BC subtending angle 32 at the circumference of the circle at point D. Now the same arc BC, now I'm using a blue ink, is subtending angle S, at the center of the circle. Oh, interesting. What does the theorem state? The theorem states that twice the angle at the circumference, so the angle at the circumference is 32, twice the angle at the circumference is equal to what? The angle at the center, BOC. That's angle BOC, and this is going to be 64 degrees. So therefore, angle BOC is 64 degrees.